Hello guys, I will cover 9-3, solving quadratic equation by completing the square today. And the main focus for today is quadratic. Okay, what is a quadratic? Now, please don't assume that because it starts with a quad, there has to be a 4. It's not true in this case. A quadratic simply means a power of 2, the highest power of 2. Okay, so here is a quick example of a quadratic expression. It can be simple as that. That is a quadratic expression. Notice I said expression because we do not have an equal sign. There's nothing on the other hand, the side of the equal sign. Now, in this case right here is a quadratic equation. This is an example, like I said, of a quadratic equation. And if you look closely, once again, it has the highest power of 2. Now, every time we see something like that, we call that a quadratic, okay? Now, what is our intended purpose for today? Well, we've learned how to factor in the past, and, everything looks good using X or Xbox. Now, the case comes down to, well, what if it's not something that is not, or what if something that's not factorable? What do we do in that case? Well, we have a way to do it, and we call this completing the square. And completing the square is nothing other than finding the PST. Well, we talked about PST before. Let's quickly review that. Now, we know PST stands for perfect square trinomial. Okay. Now, what is a perfect square trinomial? If you don't remember, let's take a look at this. Remember, our perfect square trinomial has to have specific patterns to it, and there are two distinct patterns. There is a minus plus pattern, and there's a plus plus pattern. We don't have any other patterns other than minus plus and plus plus. A good example of this would be something like x squared minus 12x plus 36. Now, I call this a PST for a reason. Now, if you look closely enough, we have here a square. We have here a perfect square term as well. If we take the square root of both right here, we would end up with x, and we end up with positive 6, right? Yes. Now, remember that because we have a pattern of minus plus, this positive 6 right here has to be a negative. Okay, a negative here will influence the 6 to make it a negative. Now, to make sure that this is indeed a PST, what we do is we times these two and double it, meaning times it by 2, and we should end up with the middle term, which is negative 12x, and we do have this checked out, and that's how we know this is indeed a PST. Okay, and let's try, of course, if you want to write it in a factor form, we'll just write it as x minus 6. You see that? That's how it works. Either this way, or you can just go ahead and write it in this compact way. There it is. Here's another example of a PST. X squared plus 8x plus 16. Now look at this, and once again, how do I know it's a PST? That's perfect square. That is a perfect square. If I take the square root of that, this is just x. This is 4, right? And this positive influence this to be simply a positive 4. I group that together, times it, and double it up. Do I have 8x? Yes, I do. So because of that, I know that this is also a PST. And once I know it's a PST, I can write out the factor. X plus 4, x plus 4, or x plus 4 square. Okay, very easy to recognize. So our purpose for today is to make sure that if I don't give you something that is a perfect square, you try to make it a perfect square. Make it factorable. Okay, so let's take a look at this right here. Here's an example. Here's an example for you. We have a squared plus 12a plus, let's say I leave this blank because, you know what, I want you to make it a PST immediately if you can. It's an expression. What do you have to have in here to make it a PST? We look at our condition once again. To make it a PST, it has to satisfy, that the first term is also a perfect square. The last term after taking the square root is also a perfect square. Whatever you have here, put together and multiply, and of course after that you double it up, we'll have 12a, right? So we know that the square root of a squared is a. We don't know what this number is, so let's leave that blank for now. We're going to put it in here after taking the square root. We know that this is a plus plus, so this remains as a positive. We times it, we double it up. We want it to equal to 12a, right? So here you can see it quite easily here, because 2 times a is already 2a. times what? Going to be 12a, and that number is going to be a 6. Don't forget this 6 is what you obtain after taking the square root, so if you have to undo it, it'll be 36. Is that true? So if we want to factor it, it will look like this. A, of course, plus plus pattern, you have a plus 6 times a plus 6, or a plus 6 squared. Now it doesn't hurt for you to just kind of check your work, making sure everything looks good. And this is how I quickly check my work. Notice that if I take the product of the inner and the outer terms, that should add up to, notice it should add up to 12a. Okay, so that's how I know it works. That's what I'm trying to ask you to find. But there is an easier way to find our 36 instead of having to go back and do it this long way. Okay, and let me introduce you that way right now. Let's go back and take a look at that problem. A squared plus 12a plus blank. Okay, I don't know what this is. I'm just trying to figure it out. Make sure that everything has to be in order from the greatest power to the least. Okay, everything has to be in order. What you do next is go ahead and pull out your coefficient from the middle. Okay, take that coefficient in the middle and you cut it in half. Notice we're actually undoing it, but here we go. You cut in half, you get back a 6. And of course, to obtain that, all you have to do is square it, and there you have it, 36. Plug right straight into there. And so that's basically the process. You take the middle coefficient, you divide it by 2, and you just square it. That's how you obtain your perfect square term on the right-hand side. Okay, now you try. Try this one. A squared minus 8a plus blank. I want you to fill in that box to make it a perfect square. Don't forget the pattern here. This is a minus 8a. Okay, so see what you have for that one. All right, let's move on to the next example here. We have x squared minus 9/2 x plus blank. Okay, now this one is a bit more complicated because you have fraction, but that doesn't change anything. All you have to do is just look for, is it arranged in order from highest to lowest? It is indeed. So once it's done, all you have to do is just pull out your coefficient from the middle. Take the coefficient from the middle, divide it by 2. Now we know when we divide by 2, involving fraction, we have to times it by the reciprocal, right? So it's simply going to become, here we go, 1/2, which will now becomes negative 9/4. And then our last step would be to undo the square root, meaning you have to square it, which now becomes 81 over 16. And that is what will go into this box. So you have x squared minus 9/2 x plus 81 over 16. This is automatically PST. You can easily factor and write it in this factor form. And how do we write it? Well, guess what? The factor form forms right there. Okay, so simply it's a minus plus pattern, so you just write x minus 9/4, x minus 9/4, or x minus 9/4 square. Okay, how do we know it's correct? Well, take a look. Is it negative 9/4 times negative 9/4, 81 over 16? That's how you quickly check it. Okay, your product here should match up in what's in the box. So your turn to try this one, please. X squared plus 7/5 x plus blank. Okay, I want you to fill in that box to make it a PST. Alright, go on to our next example involving an equation. So far we've done finding the PST via an expression. So now what if I give you an equation to solve? How do you do that? Well, in this case, let's give you something that's very easy. First, assume that this is already factored for you, meaning, I've already found the perfect square for you, and it looks something like this. How would you solve for x? Well, recall before that in order for you to access this x, we have to get rid of this, power outside, power of 2. And we learned that to get rid of power of 2, we undo it by taking the square root both sides, if you notice. If you take the square root both sides, you have that x plus 11 equals to, square root of 64 is 8. But watch out for this one right here. Remember when taking the square root of 64? Do not forget that we have two possible cases, positive and negative. Here's the reason why. With 64, we can have a negative 8 times a negative 8, or a positive 8 times a positive 8. They're both going to give you the same answer of 64. That's why we need to have two cases for it. Okay, don't forget, every time you take the square root, solve an equation taking the square root of a number, don't forget a positive negative case. Once you're done, then you can solve for x. X plus 11, to get rid of 11, minus 11 both sides. So minus 11. So what you write is negative 11, put that in front of the plus minus, okay? Plus minus 8, here's the two cases that we have. Negative 11 plus 8, negative 11 minus 8. See it? Plus 8 minus 8. You solve for it, x will be negative 3 on this one right here, and x will be negative 19 for this one right here. If you plug both in, they will work, okay? So that's how we solve for a quadratic equation. We'll get something more complicated in part 2, okay? But for now, I want you to try x minus 2 squared equals to 256. Try that one, and please observe from beginning to end. All that we've done so far involving a quadratic equation or expression, we always have something to start out with x squared. Never something, I don't have something that's the coefficient other than a 1, right? So just kind of watch out for that as we cover part 2.